Hi everyone, myself Harshini P. Raikar from Global Academy of Technology, studying in Artificial Intelligence and Machine Learning branch. Today I'm going to talk about, I'm going to explain about the coding concepts used in language detection system. So first, let me figure out what is actually language detection. What do you actually do in this? So basically, first when you when you input a piece of text written in any language. Okay, so first let me tell you where is it being used? In everyday tools like translation apps, content filters, and multilingual chatbots. Yeah, when basically the older methods used fixed rules or simple statistics, and the modern systems use machine learning to get much better results. And these systems turn text into numbers and train models to recognize language patterns in it, like how words are used or how sentences are being formed. To make this more trustworthy, AI is being used to actually see whether the model whether the model made a certain prediction. So let me share the screen of the presentation just a second. Yeah, hope this screen is being shared. The me as I told, the topic is about coding concepts in language detection system. So let me begin with the basic step, that is the data processing step. Mhm. Yeah. So basically, just a second. So what is data pre-processing? Data pre-processing is something that you pre-process the data, like you clean them, and you make the data ready for the next step, for the procedure. So yeah, like the basic step that I've used that is used in this concept is yeah. Firstly, I'm going to lowering cases it ensures that it ensures consistency across the code. If when I lower the cases, when I lower the alphabets, like lowering the cases of the alphabets. Next is the regex cleaning. So basically, what it does is it removes the special characters like URLs, etc. And it basically uses re.sub. And the next thing can be done is stop word removal. So what it does is it removes common words like the, and, etc. using nltk.corpus.stop words. So let me show you this code snippet. So as you see, so basically when the text is being entered, data it defines pre-process of text. So if I enter a text, then it basically lowers the cases, and the next is that re.sub. As I told, re.sub, it basically removes the special characters, URLs, etc. Then it basically removes HTTPS URLs are as shown, and special characters, yeah. And next is the stop word. Stop word is basically used to remove the common words like the, and as specified. So for this thing, I'm going to use the library nltk.corpus. I'm going to import stop words from nltk.corpus. And after processing data, I'm going to return the text. So next is the feature extraction step. So what it does is basically feature extraction is something extracting the most important points from extracting the most important points from code, from the code or whatever the image or whatever it is. In this pattern we basically go for. And the techniques that have been used is that TF-IDF. TF-IDF basically stands for term frequency inverse document frequency. So what is the main purpose of that? Is that it converts text into numeric vectors that reflect the word importance. Okay, so the tool that is being used is a TFID vectorizer of maximum features I've kept as 5,000. So basically, it limits the features up to 5,000 or top terms. It is not going to exceed more than 5,000 plus features. Yeah, let me show you the code snippet. Just a second. Yeah. As I told, TFID vectorizer is being imported from sklearn feature extraction dot text. Next, suppose vectorizer is being assigned, then I've kept the maximum feature to be recognized, like to be extracted is 5,000, and I'm then gonna train the vec and then I'm gonna train the vectorizer like using vectorizer fit transform of explain. Like I'm gonna train the model for it. So the next is the yeah. So the next is the machine learning models. Yeah. So machine learning models, the machine learning models that have been used are SVM, random forest, boosting, voting classifier. Okay. So let me tell you what SVM does. So SVM stands for support vector machine. Yeah, and SVM with kernels like it goes with kernels like linear, RBF, poly and sigmoid. The next is the random forest. In this, it ensembles a decision tree. A random forest is basically used as a decision trees. And the next is the boosting. In boosting, I've used as ADA boosting, gradient boosting, XG boosting. Next, voting classifier that is used like it combines the predictions from multiple models. Like it was like soft voting, basically used for like how to connect yeah. Voting classifier means it's like it connects the pattern of the text that you have provided. Okay, so that it trains the model for predicting the next thing. So these the concepts that have been new. The main thing is supervised learning, classification, and ensemble learning. Under supervised classification, yeah, okay. So next is I'll let you show the code snippet. Yeah, I've used SVM from which SVC is imported, and for ensemble, I've used like a random forest classifier, basically used for decision trees, and SVM, it goes with linear, and yeah, next is here I've used random forest classifier for the classification purpose, and okay. Next is model evaluation. So model evaluation is something like you're going to evaluate the model's accuracy, precision, recall, and F1 score. So basically, confusion matrix that it visualizes true versus the predicted labels. And the tools that are directly used is sklearn.metrics. Since like machine learning basically allows like for machine learning basically what is it like it makes it easier to process the codes by providing libraries like like combined with Python. Like yeah, Python provide libraries which makes machine learning models to get much more greater accuracy and makes it easier to code. And yeah, these are the code snippets of the uh, model evaluation. It basically I'm like this is like I'm predicting the score. I'm predicting okay. So import I'm using from sklearn.metrics. I'm importing like accuracy score, precision score, recall score, FN score, and confusion matrix. So Y predict is being like it assigned as a SVM model dot predict of X dot test TFIDF. So it basically predicting basically predicting the model of like which is assigned to X test dot TFIDF. Okay, so now I'm gonna print the accuracy precision. It's basically gonna give me the output of accuracy precision. Okay, the next is that I'm going to print recall, I'm going to print FN score, I'm going to print confusion matrix. Okay, So the next is the hyperparameter tuning. Yeah. The next is the hyperparameter tuning. Here it's like mm, yeah, methods that have been used are grid search, SCV, and hyperopt and hyper grid search CV and hyperopt are being used for hyperparameter tuning. So grid search CV, what does it does? It basically tries all the combination like exhaustive. It tries, it's like it gives a trial and error for everything. Next is the HyperOp. It uses Bayesian optimization. It's like efficient. A grid search is exhaustive because it goes on trying all the combinations, and HyperOpt is efficient because it's like goes only which is efficient, which is only sufficient for the model, and it's also which tunes only the efficient parameters, like making which tunes the models is like making it efficient. So the purpose is that it finds the best parameters to improve the model performance. Yeah, like grid.cv, it tries all the combination, and upon that we go for hyperopt. Basically, like after upon trying, we go for like certain best parameters, and then like yeah, the purpose is like and improve. The purpose is to improve the model accurate performance. Yeah. So this is the code snippet. Hmm. Okay, grid search CV is being imported from model SK-learned model selection library itself. Okay, and yeah, and the kernel that is being used is linear and RBF, and so RBF basically is, let me tell like mm, mm. So let me tell you like what is RBF? Like RBF stands for it basically stands for radial basis function. Yeah, it is especially SVM that refers to a popular kernel function to transform input data into a higher dimensional space. Okay. Hmm. So like yeah, I hope you got an idea of RBF since I've been since I've been using it from a long time. Okay, the next is yeah, grid search. A CV tries all the parameters, like it tries all the combinations, and I'm gonna train it, like I'm gonna fit it like that is X train and Y train, and yeah, I'm gonna find the best parameters out of them. Next is the explainable AI, that is XAI, which is also like reduced into XAI. Like yeah. Um. mm, mm. So explainable AI that have been used are like LIME, that basically explains how individual predictions. Okay. SHAP shows feature impact globally and locally, and goal is to make the model decisions interpretable, so that it helps the decision, like so it makes the model easier to interpret the decisions. Okay, so probably you might getting an idea, like you might getting a question like what is LIME and what is SHAP. So let me give you just about those two methods. Like yeah, LIME basically stands for local interpretable agnostic explanations. So the purpose is that is like explains why a machine model made a specific prediction for a single data point. Okay, how it works and all, like let me not go that brief. And then next is like you might get an idea, like you might get a thought like what is SHAP. So basically SHAP stands for shapely additive explanations, and so the purpose is that like explains the impact of each feature on model's output both locally and globally. Like locally means like per prediction, and globally means like overall model behavior. But then LIME is for just a local explanation that is like per prediction and not overall model behavior. Okay, so let me show the code snippet. The code snippet goes like I'm gonna import SHAP and yeah, that's what I'm gonna use SHAP. I'm gonna use SHAP because it is more helpful. Like it is more accurate. It helps us in both way, like locally and globally too. Mm. Okay, next is the lightweight language detection. Mm. Uh, okay, I can actually give you the difference between LIME and SHAP. So basically, LIME it's like a local explanations only, and SHAP it's both local and global explanations, and it's based on like a simple model fitting, and SHAP is used for like game theories. Okay. So the output would be of LIME goes like feature importance only, like locally. It won't go for globally, and SHAP, it's like globally and locally both feature importance. And yeah, that's it. Like, let me go to the next topic. That is lightweight language detection. Mhm. Okay, probably people might be like, what is lightweight language detection and all? So let me brief you about that. Mm. So that is mainly used for like smaller data sets or faster deployment. Okay. Use cases are like for smaller data sets or faster deployment. Okay. So the approaches that have been used for lightweight language detection are it uses SVM or random forest as briefed earlier. You're gonna get an idea of those things. And you use like I've used RTF, IDF factorizations. Yeah. And it basically saves the models using job light. Yeah, these are the concepts and hmm, okay, yeah. Mm, okay, the concepts under this are lightweight machine learning, serializations, inference pipeline. Okay, so now you might get an idea. You might get a question like, what is serialization and what is serialization and inference pipeline, right? Like Okay, so just let me just give you a small gist of those things. So what is serialization? So serialization is basically a process for saving a trained model and other components. Okay, just basically save the models uh, so that it can be used without retraining any components or any parameters. And as you yeah, and next is the inference pipeline. Inference pipeline is something like it's a sequence of steps to new or unseen data. Okay. It is used for making predictions that is used for saving the model. Okay, I hope you got a small idea of what is inference pipeline and what is serialization. Okay, the next let me show you this code. Let me show you the code snippet. Okay, so yeah, job live is used for saving the code. Okay. So yeah, I'm gonna save this and load the model. I'm loading the model into SVM model and vectorizers. Okay. So next is the hybrid detection mechanism. Okay. So in this, okay, let me brief you about this now. Yeah, so you might see like what is primary tool, like what is primary tool of feedback or like what all those things. So basically primary tools are like lang detect, that is language detect, that is used for like unsupervised, yet it is unsupervised yet faster. Then fallback, sorry, not feedback, it's fallback, yeah. Yeah, fallback is like use SVM or RF. Like SVM, that is as I told, it is support vector machine, and RF is like random forest. If language, yeah, if something like if the language detection fails, that is the if the primary tool fails, or is it is used like, oh wait, okay, let me tell it this way. If the primary tool if the primary tool fails, then fallback comes into action. Okay, so basically it increases the robustness and accuracy of the model. So primary tool is something like primary tool, suppose if I use language detect, it is unsupervised yet faster. So then if the language detect, I mean lang detect fails, then fallback, that is like use of SVM or like support vector machine or random forest comes into action to maintain the robustness and accuracy of the model. Okay, let me show you the code. Mm. Okay, so this is the code like language detect. I'm being import from language detect. I'm going to import detect, and so language lang detect expect exception. Okay, so if if detect language or like define, if I define okay, if detect fails and I can give an exception as a exception for lang detect exception so that the fallback comes into action. Okay. So this is basically, it explains this part, basically explains the topic which was specified in the previous slide. Okay. So next is the feature importance visualization. Okay. So in this, like, what are we going to cover? It's basically, it's like, a feature important for feature important importance visualization, I use tools like feature importance, like a random forest feature importance, I can say, which is being used. Then for visualization, I'm like top 10 features can be shown with matplotlib. Okay, so I hope you people, I hope those who ever uses Python are familiar with matplotlib. Okay, and if yet you're not familiar, I can give you, like, I can just brief it out. Just a second. So Matplotlib is something like, it's a Python library. If you're familiar with Python, then of course Matplotlib is a friendly purpose. So for creating it is basically used for creating a static, interactive or animated visualizations. Okay, so it's especially popular for plotting data in scientific and machine learning projects. Yeah, so I hope you got a just on math.live. Okay, so next is the concepts that have been covered is visualization, interpretability, and feature selection. Okay, so this is the code snippet. Yeah, I'm going to import a PLT, that is to plot a point, as I told in the definition. And next is the NumPy as like NP. Mm, yeah, this is the basic code. Feature importances, like suppose feature importances, like I'm going to use random forest model for dot feature importances. Okay, then feature names for vectorizer.get. I'm going get feature names. I'm going to use vectorizer model and random forest model, and then I'm going to use np.r arg sort, that for feature importances I'm setting the range from -1 to 10. Okay, so then plot figure, it's like, yeah, a figure size of 10 comma 6, and plot bar of NP. Like I'm gonna use feature names sorted IDX of this np.arg sort. Then feature importances of sorted IDX, and color would be a sky blue. Sorry, yeah, I couldn't paste the output, but yeah. Then I'm going to plot X label as feature importance, and title would be given as top 10 features, and yeah. Mhm. And then I'm going to convert it into invert y-axis. Fine. Then I'm going to plt.show is going to show me the entire, like, show me the bar chart. Okay, and show me the figure. So next is the that's it for now. Like that's it. I'm going to end this now. So the last thing is like conclusion. I'm going to conclude in a way like. Yeah, this model is like comprehend. Whatever I covered is that I gave a comprehensive overview of the language selection system. Yeah, and I've shown like integration of pre-processing, feature extraction, model training, evaluation, and explainability of like the complete system. And yeah, we also covered that how okay, so hybrid detection mechanism and model interpretability. So yeah, that's it for the explanation. Uh, Thank you. And Yeah, that's it.